Good morning, children. Yesterday, as we have started sulfur, 16th group element, in that started allotropes of sulfur. As per the syllabus, we need to discuss about the sulfur dioxide, preparation, properties and uses. Similarly, sulfuric acid only preparatories and uses. As per the syllabus, they have removed manufacture of sulfuric acid by contact process in the updated syllabus. Other than that, we have to discuss about only the structure of oxo acids of sulfur. Oxo acids of water, sulfur. Based upon all these, as we have started in the last class, sulfur, let us move to sulfur dioxide. Sulfur dioxide, SO2. It is an angular molecule, which can be resonating structure can be represented as, or even we can write it as S double bond O. Okay, resonating structure means what? Where delocalization of pi electrons will take place. Okay, now let us talk about the yesterday's question. Oxygen and the ozone both are neutral to litmus paper. Many of the children have answered. Very good. Keep it up. In the same way, go for answering. One of the two have committed mistake that they have written ozone is an acid. No. Ozone and oxygen both are neutral in nature. They will not change the color of the litmus paper. Okay, that's why the yesterday's question as I asked, what is the litmus paper action on ozone and oxygen? Let us move to the topic, sulfur dioxide, methods of preparation. Preparation is very simple that sulfur dioxide are prepared by burning elemental sulfur. By burning elemental sulfur, or we can take any sulfide ore like copper pyrite or the iron pyrite, which on burning they are going to produce water, they are going to produce sulfur dioxide. Elemental sulfur on combustion, will produce sulfur dioxide. Same way, the iron pyrite, FeS2, even you can take copper iron pyrite like CuFeS2 also. Okay, or we can take CuS also, ZnS also. Any of the sulfide ore, when they undergoes roasting, that is water heating in presence of air or oxygen, they are going to produce water, Fe2O3, along with the liberation of sulfur dioxide. Along with the liberation of what, children? Sulfur dioxide. Let us balance the equation. 2 2s are 4, 4 sulfur, 2 Fe is balanced. How many oxygen are there? 3, 4 2s are 8. 8 plus 3, 11. We can write it as 11 by 2. As we know that to write a whole equation with the whole number, necessary to multiply whole equation by 2. FeS2 plus 11O2 converted into 2 Fe2O3 plus 8 SO2. So we can say that whenever we are, this is S, 8 SO2. It is looking like 88. Okay. So here we can say that whenever we are going to take with respect to the combustion, okay, combustion of what? Elemental sulfur, or we can say that iron pyrite ore, or we can take with respect to what? Sulfide. That is, whenever we are going to take with respect to the sulfide, SO3 2 minus, like the sodium sulfide. Okay, like the sodium sulfide, or we can take any sulfide. When sulfide are treated with water, acid. When they are going to be treated with acid, H plus, because 2 minus are there, that's why I have written directly SO2 plus H2O. SO2 plus H2O. So we can get it as water. This will be 3. So here we can say that these are the 3 methods are there by which we can manufacture sulfur dioxide, by which we can prepare sulfur dioxide. These 3 methods are familiar method. Either by burning the elemental sulfur, or by taking this iron pyrite as I said that any of the sulfide ore can be taken, because in the metallurgy we have studied. Okay, as you know that metallurgy topic is eliminated from our syllabus, but we have studied in the high school that sulfide ore are subjected for roasting. Same way, same concept we are applying over here. Then sulfide ore subjected for roasting, we are going to get what? Sulfur dioxide. Sulfur dioxide. This is all about the three methods of preparation. Okay, by burning with water, elemental sulfur, by burning with elemental sulfur. Elemental sulfur will produce sulfur dioxide. Same way, this one sulfide ore will produce sulfur dioxide. Sulfite are converted into sulfur dioxide. These are the three methods are there. This will be possible in acidic medium. This is ionic reaction. In acidic medium, we are going to get what, children? We are going to get sulfur dioxide. Sulfur dioxide. And remember here, whatever the sulfur dioxide is going to be obtained, it will be converted into liquid under high pressure. Now the question arises that what are the properties? What are the physical properties of sulfur dioxide? It is a colorless gas with pungent smell. What it is? It is a colorless gas with pungent smell. We will write the physical properties and as well as chemical properties. Let us move to physical properties of sulfur dioxide. Physical, chemical properties and uses. With this it will complete group 16 elements. We will move to physical properties of sulfur dioxide. Physical properties. Physical properties. It is a colorless gas with a pungent smell, highly soluble in water. Colorless gas with pungent smell. Pungent smell means what? Very bad smell. Bad smell or disagreeable smell are called as pungent smell. Highly soluble in water. It is soluble in water. Soluble in water. Children, have you remember that in the environmental chemistry in first year we said the gases responsible for acid rain is oxide of sulfur, oxide of nitrogen and oxide of carbon. These are the gases which are responsible for acid rain. The gases which are responsible for acid rain, because when sulfur dioxide are going to be dissolved in water, it is going to produce sulfurous acid. Okay, let us move to the one by one in chemical properties. Chemical properties. Okay, first one we'll see reaction with water. Reaction with water. What happened? When sulfur dioxide reacts with water, it will produce what? Sulfurous acid. It is going to produce what, children? Sulfurous acid. Sulfur dioxide in water. Okay. Sulfur dioxide when dissolved in water, the gas which is responsible for acid rain. The gas which is responsible for acid rain are going to produce, because sulfur dioxide is a weak acid, they will attain equilibrium to get H2SO3, sulfurous acid. Sulfurous acid. Same way, the second one is what? Contact process. What is contact process? When sulfur dioxide undergoes combustion, we can write it as combustion of sulfur dioxide. Combustion of water, sulfur dioxide. When sulfur dioxide undergoes combustion in presence of vanadium pentoxide as a catalyst, it will produce water sulfur trioxide. That method is called as contact process. Contact process for water, manufacture of sulfuric acid. Actually, contact process they have eliminated from the cellulose. Okay, so here we can write it as sulfur dioxide on combustion. On combustion will produce sulfur trioxide in presence of vanadium pentoxide as a catalyst. Vanadium pentoxide which convert sulfur. Actually, contact process involve sulfur dioxide to sulfur trioxide to oleum, oleum to sulfuric acid. H2S2O7 are called as oleum. So we can say that whenever this combustion of sulfur dioxide takes place, in present this reaction is most important in contact process, because in presence of vanadium pentoxide it is possible. Okay, and this method is named as what, children? Contact process. Contact process for what? Manufacture of sulfuric acid. In the same way, when sulfur dioxide heated with chlorine gas, it will produce sulfuryl chloride. Next one, we can write action with chlorine gas. When they are going to react with chlorine gas, they are going to produce what, children? They are going to produce, third one, reaction with chlorine. They are going to produce sulfuryl chloride. Reaction with chlorine. Reaction with chlorine. We can write it as sulfur dioxide with chlorine. When sulfur dioxide is treated with chlorine, they are going to produce sulfuryl chloride as SO2Cl2. As SO2Cl2 in presence of catalyst. This is called as sulfuryl chloride. Sulfuryl chloride. What we can call it as sulfuryl chloride. Now, as I said that sulfur dioxide is weak acidic in nature. The one of the gas responsible for acid rain is sulfur dioxide. It means that sulfur dioxide, when treated with base, they can form salt and water. It means that sulfur dioxide is acidic in nature. Let me repeat the sentence. Sulfur dioxide is acidic in nature. Sulfur dioxide nature is what? Acidic in nature. So it has the character to combine with base. It has the character to combine with base, like sodium hydroxide, potassium hydroxide, calcium hydroxide, etc. When they react with the base, they are going to produce what, children? They are going to produce salt and water. They are going to produce water, salt and water. We'll see acidic nature of sulfur dioxide. Acidic nature. Acidic nature of sulfur dioxide. When sulfur dioxide treated with base like sodium hydroxide, they will produce salt as sodium sulfite, Na2SO3, along with water. Na2SO3 along with water. Balance the equation. Na2SO3, 2Na, 2 hydrogen are there, oxygen 4 are there. Yes, it is balanced. This is sodium sulfite. Sodium sulfite. This reaction with base indicates that sulfur dioxide is acidic in nature. Due to their character as acidic, it can act as a bleaching agent. What do you mean by bleaching agent? Which can convert colored substances into colorless. Which can convert what? Colored substances to colorless. They are called as bleaching agent. They are called as what, children? They are called as bleaching agent. Sulfur dioxide not only a bleaching agent, even it can act as a reducing agent also. And during reducing agent, it can convert ferric oxide, that is Fe3 plus salt, ferric salt, not oxide. Ferric salt converted into ferrous salt. They are converted into what, children? Ferrous salt only in water, acidic medium. We will write fifth one. It can act as a, we will write one by one. It can act as a reducing agent. It can act as a reducing agent which can convert ferric salt to ferrous salt. Fifth one, it can act as a reducing agent. It can act as a reducing agent which convert ferric ion to ferrous ion. Ferric Fe3 plus. Fe3 plus by passing sulfur dioxide in aqueous medium converted to ferrous Fe2 plus. Ferric converted into ferrous. Ferric converted into water, ferrous along with the sulfate. And as well as acid. Fe2 plus along with SO4 2 minus and acidic medium. So we can balance the equation. How many this one are there? Hydrogen 2 are there. Then sulfur, how many are there? 2 plus 1, 3. This will take it as 2. This we can write it as 4. Okay. This we can write it as 4. Yes, it is balanced. So we can say that ferric salt. We can take ferric sulfate converted to ferrous sulfate. Any of the salt you can take in the ferric medium to ferrous salt. So here these are the reaction. What does it indicate? Sulfur dioxide reacts with water to produce sulfurous acid. Okay. Other than that, sulfur dioxide acts as acidic in nature. That's why it can react. But remember one thing, it is a weak acid. Sulfur dioxide is a weak acid. It can produce a sodium sulfide. It will produce what? Sodium sulfide. Same way when it is treated with chlorine, it can produce sulfuryl chloride. It can produce what? Sulfuryl chloride. Same way, it can convert ferric ion to ferrous ion. Remember here, it can act as a reducing agent. Other than ferric ion, if we are going to take manganate ion also, same reaction are going to take place. Manganate ion with the sulfur dioxide, same reaction are going to take place. So these two reactions, this I am writing excess, this reaction we have not mentioned in our NCERT syllabus. So we can write it as manganate, potassium permanganate are converted into water, manganese sulfate. So here Mn2 plus, manganate ion are converted into Mn2 plus ion. This is also due to the reducing nature of sulfur dioxide. This completes the chemical properties of sulfur dioxide. What are the uses are there? Sulfur dioxide can be used as a reducing agent. As we said just now, it is a reducing agent. It can be act as a bleaching agent. It is used in the preparation of sulfuryl chloride. It is used in the preparation of sulfur trioxide. So remember one thing, these are some of the uses are there where we are going to use. Other than that, sulfur dioxide can also be used as disinfectant. Sulfur dioxide is used as what, children? Disinfectant. Okay, this is all about the one of the compound or the oxide of sulfur, that is sulfur dioxide. Next is what? Oxo acids of sulfur. Only structure we need to discuss. Remember here, sulfur is hexavalent because atomic number of sulfur is what? 16. It will comes under which group? NS2, NP4. So valence electron, how many are there? 6. Oxoacids of sulfur. Oxoacids of sulfur. 4 they have mentioned in our syllabus. Only structure we need to write. Remember here all this structure to calculate oxidation number. Already we have written in first year. These structures are not new for you. All these are familiar. In the redox reaction topic, we have studied to calculate oxidation state. But here we are going to write their structure. Oxoacids of sulfur. Oxoacids. Oxoacids of sulfur. Oxoacids of sulfur. Oxoacids of sulfur. As I said that in the updated syllabus they said to write only structure. First example, like sulfurous acid. Sulfurous acid H2SO3. Sulfurous acid is what, children? Sulfurous acid is H2SO3. S double bond O, okay, OH. Because we are having sulfurous acid with respect to what? S double bond O, okay. Here we are having OH. Remember one thing, whenever we are going to write, whenever we are going to calculate the oxidation state, okay, it should not be more than its valency. Okay, then we can write lone pair of electrons. Same way, sulfuric acid, sulfuric acid H2SO4, S double bond O, OH and OH. If we calculate the sulfur oxidation state, this will be -2, okay, this will be what? -2 plus 1. This will become it as -1. So total will be what in the same way? -6. Then sulfur oxidation state will be +6. We have written in first year. Okay. Next is oleum. H2S2O7. Okay. Oleum, which is also called as pyrosulfuric acid. Oleum is also called as what, children? Pyrosulfuric acid. The name is pyrosulfuric acid. Okay. S. 2 sulfur are there. Double bond O. Same elemental representation for both the sulfur. OH. This will also be OH. Okay. Double bond O. Now how many oxygen left out? 1. We will write it as like this. S2, H2, 1, 2, 3, 4, 5, 6, 7. H2S2O7. That is a pyrosulfuric acid. It is what, children? Pyrosulfuric acid. Same way, the last example is peroxodisulfuric acid. H2S2O8. Is it visible? Shall I write here? Peroxodisulfuric acid. H2S2O8. Only the difference between oleum and this is here we are going to write OO. S double bond O, OH, O, S, OH, double bond O, double bond. In this case also sulfur will be +6. So don't think that sulfur oxidation state will be more than 6 because oxidation state cannot exceed its valency. That's why we can say that based upon the structure, -2, -2. When we are taking the peroxide, it will become it as -1. Oxidation state of oxygen in peroxide will be -1. That's why the resultant. Because the sum of oxidation state of all the elements in a molecule is what, children? It will be 0. That's why we can take it as here +6. This will also be +6. This is all about the peroxide. That is oxo acid of sulfuric acid, like sulfur like sulfurous acid, sulfuric acid, oleum, and peroxosulfuric acid, peroxodisulfuric acid. As they have mentioned in the syllabus, only to write the structure. This structure already we have written in first year, children. You may be remembering. These are familiar to us. There we have calculated their oxidation state of sulfur. Okay, we have calculated oxidation state of sulfur. Let us move to water. Sulfuric acid. As I said already that as per the syllabus we need to discuss only properties and uses of sulfuric acid, because in the updated syllabus they have eliminated manufacture of sulfuric acid by contact process. Let us move to sulfuric acid. This is the ending part of group 16 elements. Group 16 elements. 17 and 18 will not take much time. Only the nitrogen family is little bit lengthy. Okay, you will be remembering that we have taken around 4.5 hours to complete group 15. Okay, let us move to sulfuric acid. King of chemicals. Sulfuric acid. H2SO4. It is oxo acid of sulfur. Just now we have written it is a dibasic acid. It is a dibasic acid. Dibasic acid, king of chemicals. It is one of the important lab reagents. Sulfuric acid is important lab reagent, but it is skin corrosive. Skin corrosive. Concentrated sulfuric acid, we should be very careful while handling in the lab. One more thing have you observed in the lab, children? Sulfuric acid when dissolved in water, it will give exothermic reaction. Sulfuric acid when dissolved in water, it is producing water, liberating enormous amount of heat energy. Okay, enormous amount of heat energy, it is an exothermic reaction. That's why while preparing the diluted acid, necessary to put little amount of sulfuric acid in water with continuous stirring. Means acid in a small quantity. Acid in what, children? Small quantity should be added slowly to water with stirring. Means continuously we have to go on stirring, because beaker will become very hot because of exothermic reaction. Because of what? Exothermic reaction. That we need to be observed over here. That we need to be remember over here. Now the question arises that what are the properties? As I said, we are not going to discuss any preparation. Physical properties. Already as we know that it is a colorless liquid, it will be a viscous liquid. Colorless, viscous. Viscous liquid. You might have observed in the lab that while putting the sulfuric acid, whole test tube will become hot. That's why we should be careful over there. We should be very careful while handling the experiment, especially with concentrated sulfuric acid. Sulfuric acid, whose specific gravity is around 1.84. Specific gravity is how much? It is a viscous liquid. 1.84 at 298 Kelvin of temperature. What? At 298 Kelvin of temperature. Let us move to the important part of the topic, That is chemical properties of sulfuric acid. Chemical properties. Chemical properties of sulfuric acid. What happens when sulfuric acid undergoes decomposition? When sulfuric acid undergoes decomposition, it is going to produce sulfur trioxide. Sulfur trioxide. Chemical properties. Chemical properties of sulfuric acid. The first one is dissociation. Dissociation. When sulfuric acid H2SO4, as I said already that it is a dibasic acid. That means that it has two replaceable hydrogen atom, or we can say that it has two replaceable hydrogen ion. That's why it is called as basicity is 2. When sulfuric acid, when we are going to write dissociation, it is going to produce what? H plus and SO3. Okay, sulfur trioxide are going to be liberated out. Sulfur dioxide gas is going to be liberated out, and we are going to get whatever. Along with this, we are going to produce H2O. Sulfur trioxide gas is going to be liberated out. Remember one thing, when these two are going to treat, again we are going to get like a reversible process to get sulfuric acid. Other than that, as we know this one, the acidic nature of any this one acid can be decided on the basis of what, children? Ka value. That is, higher is the value of Ka, stronger will be the acid. Stronger will be the acid, and as we said that it is a king of chemicals. From this name itself, it indicates that it may have higher Ka value. Do you know the Ka value of sulfuric acid is more than 10? More than 10. Usually carboxylic acid we have studied in organic chemistry. All the values are what? Like formic acid 10 to the power minus 4. Acetic acid 10 to the power minus 5. But this one is 10 to the power plus 1. That's why it is called as king of chemicals. We'll write acidic nature. We'll move to the property. Most important property of sulfuric acid, like acidic nature. Acidic nature of sulfuric acid. Acidic nature of sulfuric acid. Acidic nature. When sulfuric acid in aqueous medium, it will produce H plus along with HSO4 minus. Same way, HSO4 minus, okay, this will be in the form of what? Even we can write it as H3O plus also, like hydronium ion, or in a simple way. Instead of writing protonated water, directly you can write proton also. It doesn't make any difference. This will be converted into water. In aqueous medium, they are going to produce H plus and SO4 2 minus. Ka value is very high. It will be greater than 10. Higher is the Ka value because Ka value is directly proportional to strength of acid. Ka value is directly proportional to what, children? Strength of acid. That's why we can say that sulfuric acid is the strongest acid. King of chemicals, it is a strongest acid. Ka value, because we know very well that pKa is inversely proportional to strength of acid, but Ka is directly proportional to strength of acid. To support that it is acidic in nature. So sulfuric acid can react with base. like sodium hydroxide to produce sodium sulfate and water. Like sodium carbonate, it will produce sodium sulfate along with the liberation of carbon dioxide. One by one reaction we'll see, children. When they are going to be dissolved in water, as we said that it is a dibasic acid which will produces 2 proton. Which will produce how many proton? 2 proton. Reaction with base like sulfuric acid base reaction with sodium hydroxide will produce sodium sulfate along with water. Along with what, children? Water. Same way we can write as 2 2s are 4. Then sodium carbonate with sodium carbonate, H2SO4 with sodium carbonate, metal carbonate. Not only with the base, even metal carbonate. Have you remembered, children? Sodium carbonate, when dissolved in water, it will turn red litmus paper to blue. What does it indicate? Sodium carbonate nature is basic in nature. That's why sodium carbonate solution will call it as what? Alkaline solution. Sodium carbonate, it will produce sodium sulfate, Na2SO4, along with the liberation of carbon dioxide and water. Carbon dioxide and water. So what we can say, children, here? Acid, being acidic, because K value is more than 10. It means that it is a strong acid. When it reacts with the bases like sodium hydroxide, or when it reacts with metal carbonate like sodium carbonate, or when they are going to react with basic oxide. Because what I said, they are having the nature of acidic. Even they can react with the basic oxide like calcium oxide. They are going to react with calcium oxide. Sulfuric acid along with calcium oxide. It is a basic oxide which will produce calcium sulfate with water. Either it can react with base, it can react with metal carbonate or metal oxide. What it is going to produce? Salt and water. Salt and water. That means that this reaction indicates that sulfuric acid is acidic in nature. Another point, have you remember in the organic we said, that is esterification reaction. Not only in esterification, even in the biomolecules I said to you. Whenever the sugars are heated with concentrated sulfuric acid, dehydration takes place. They are converted into, sugar is converted into black mass of water, carbon. It is called as what, children? Charring of sugar. Those reaction will see. Dehydrating nature. Third one, sulfuric acid act as a dehydrating agent. Sulfuric acid acts as a what, children? Dehydrating agent. Not only in esterification. Have you remember that whenever it can act as a dehydrating agent, only for such a reaction where it cannot react. In previous group 15 I said, ammonia cannot be dried by sulfuric acid. Why? Shall I write today's question? Why does ammonia cannot be dried by sulfuric acid? Write the today's question. Why ammonia cannot be dried? Very simple. Already I said this concept. We want to check that have you remembered earlier group or not. Why ammonia cannot be dried? By using sulfuric acid. By using what? A sulfuric acid. We will come to the point. Dehydrating agent. It will remove water molecule. For example, in all the cases, water is eliminated. Water is eliminated. That's why these are called as what, children? Dehydrating agent. They are called as what? Dehydrating agent. Okay. Example like sucrose. Example of dehydrating agent, C12H22O11 table sugar. When heated with concentrated sulfuric acid, they can produce carbon along with water. This process is called as charring of sugar. Charring of sugar. Sugar converted into black mass of carbon. Sugar converted into water, black mass of carbon. It is called as charring of sugar. Same way, when ethyl alcohol heated with concentrated sulfuric acid at about 170 degrees Celsius will produce water, ethene. Colorless gas is going to be liberated out along with the water. Along with the water. Formic acid with concentrated sulfuric acid on heating will produce carbon monoxide and water. Carbon monoxide and water. Oxalic acid is a dibasic acid. Oxalic acid is a dibasic acid. This is familiar to you. Formic acid. Oxalic acid, dibasic acid on heating with concentrated sulfuric acid will produce two oxide, carbon monoxide and carbon dioxide. Okay, carbon dioxide is acidic in nature, carbon monoxide is neutral in nature, along with water. So we can say that some of the examples I have written, but in NCERT they have given only one. But for the need purpose, you need to. This is already we have studied in alcohol, phenol, and ether. Only these two reactions. That too, this reaction is most important for need. Name the gases liberated when oxalic acid is heated with concentrated sulfuric acid. It will produce carbon monoxide and carbon dioxide. Carbon monoxide and carbon dioxide. Sulfuric acid can act as acid, strong acid. It can act as a dehydrating agent. Even it can react with the bases or the metal carbonate or basic metal oxide to produce salt. Now, other than that, one more thing you need to remember, that sulfuric acid act as a oxidizing agent. Sulfuric acid act as a oxidizing agent, which can convert water. Carbon, when treated with concentrated sulfuric acid, it is converted into carbon dioxide. Copper to copper sulfate. Like that, we will see one by one reaction. Oxidizing nature of sulfuric acid. Well, right. Oxidizing nature of sulfuric acid. Maybe fourth. Oxidizing nature. Oxidizing nature of sulfuric acid. What I said, sulfuric acid can act as a best oxidizing agent, or it will be a moderately strong, not weak. Moderately strong oxidizing agent which can produce nascent oxygen. Because of that reason, it acts as a oxidizing agent. Oxidizing agent which can convert carbon to carbon dioxide. Converted into what? Carbon dioxide, sulfur dioxide and water. It can convert it into what, children? Carbon dioxide, sulfur dioxide, and it can going to produce even water. Write the balance equation. We'll write it as, this will write it as 2. This will be 2. Correct? 2 sulfur is balanced. Oxygen, how many are there? 2 4s are 8. 2 2s are 4. 6 and 8. 6 and 8. So it can produce what? It can convert carbon to carbon dioxide. Same way it can convert sulfur to sulfur dioxide. Sulfur, elemental sulfur. It will produce water, sulfur dioxide and water. Sulfur dioxide and water. How many are there? This will write it as water. 2. 2 plus 2, 4. This I'll take it as what? 2. No. Balance only, no? 2. We can write it as 2 2s are. This sulfur will become how much? 3. This if I am going to take 2 4s are 8. 3 2s are 6 plus 2, 8. Sulfur to what? Sulfur dioxide. Even when it reacts with the least reactive metal atom like copper, it can convert it into copper sulfate and sulfur dioxide. Copper with sulfuric acid. Copper with sulfuric acid will produce what? Copper sulfate, CuSO4, along with the liberation of sulfur dioxide and water. Balance this equation yourself. So we can say that all these reaction indicates what? Sulfuric acid can act as a what? Oxidizing agent. Sulfuric acid, concentrated sulfuric acid can act as a oxidizing agent. It can act as a dehydrating agent. Rather than this one, the most important reaction is, even this we have studied in what? Electrochemical series. In electrochemistry we said zinc can liberate hydrogen gas when treated with dilute acid but not copper. Because copper has how much SRP value? Plus, it is a positive, plus 0.34 volt. Whereas the zinc is having minus 0.76 volt. Because of this reason, we can say that because of the electrode potential, this is inactive metal, zinc is a active metal. Okay, what are the uses are there? Sulfuric acid can act as a. What are the uses? Uses of sulfuric acid. Uses of sulfuric acid. As we said just now, it can act as a dehydrating agent. Dehydrating agent. It can act as an oxidizing agent. And that too it will be mild strong. Mild strong. Oxidizing agent. Other than that, even it can be used. It can be used as a what? As a lab reagent. King of chemicals. As a lab reagent. As a lab reagent. Other than that, it can be used in the preparation of dynamite, explosive, or trinitrotoluene, TNT. Children, have you remember this one reaction we have performed in lab, that is during the this one volumetric analysis. 2 experiments we have performed, one volumetric analysis and one qualitative analysis. In the semi-micro qualitative analysis of inorganic salt, we said to identify the second group acidic radical. Whenever the metal ion, that is a metal salt like NX, treated with sulfuric acid. Treated with water, sulfuric acid, they are going to liberate HX gas. You may be remembering this reaction, that metal salt, whatever the salt is given to you, treated with concentrated sulfuric acid on heating, where X may be Cl, Br, even we can take nitrate. Just to recall, this we have performed because iodide salt is not there for the syllabus. That's why we have taken chloride, bromide and nitrate. They are going to liberate colorless gas with pungent smell. It shows the presence of chloride ion. It shows by heating reddish brown fume. It is a bromide. Without heating, if you are going to get a reddish brown fume, it is a nitrate. That also we can write it in the method of water in the qualitative analysis as the uses we can write. Okay, this completes group 16. In the group 16, what we have discussed, children? We have discussed about the occurrence, general trends, then chemical properties, that is the reactivity, then anomalous behavior of oxygen, then allotropes of oxygen like ozone. We have discussed before this one ozone, oxygen preparation, properties and uses, dioxygen. Same way ozone, preparation, properties and uses. Next is allotropes of sulfur, then related with sulfur dioxide, preparation, properties and the uses, and as well as sulfuric acid, preparation, preparation is not there. They have eliminated for updated cells. That's why we have discussed whatever, we have discussed their properties and uses. Let us move to next group, that is group 17 elements. Still time is there, we will continue. Group 17 elements. Group 17. Now you got the familiarity with group 16 and 17. Okay. As we have discussed already, group 14, okay, group 15, this one, 13 and 14 we have studied in first year. 15 we have completed last week, then 16 we have completed just now. Now we are going for group 17. Group 17, what is the other name of group 17? Group 17 are called as halogen. Group 17. Group 17 elements. They are called as halogens. It is a Greek word. It is a Greek word where halogens means salt producer. Salt producer. It is a Greek word. Okay, halogen are Greek word which means salt producer. Which are the elements are there? We will write fluorine, chlorine, bromine, iodine and aspartame. As we know very well that like in the group 16 we said polonium. In previous group also as I said that always whichever the group you are going to discuss, first you write elements one side. Which are the elements are there in that group, that you write one side. Okay, these are having what table? These are having electronic configuration as NS2NP5. Group 15 was NP3. Group 16 was NP4. Group 17 is NP5. With that only it can indicate that it has the character to accept the electron rather than losing the electron. Rather than what? Losing the electron. Occurrence as usual. Occurrence. Fluorine, chlorine, bromine, iodine and astatine. Astatine is a radioactive metal atom. That's why we are not going to discuss much related with astatine. In the occurrence we can say that they are very reactive. So it means that they cannot exist free. They are very reactive. They cannot exist free. They cannot exist in free state, but they can exist in combined state. They can exist as the combined state. In that combined state, chloride and bromide. In the combined state, all the halide except astatine are found in the earth crust, where fluoride and chloride are abundant, fairly abundant, whereas bromide and iodide are less abundant. Usually fluoride will be present as in this one. In the phosphorus we said the fluorspar. Even the fluoride content, they are present in what? Bones and teeth. They are present in bones and teeth. Okay, like the fluorspar. Calcium fluoride. Okay. We can say that whenever we are going to take, even we can take with respect to what? Cryolite, Na3Al(F6). Cryolite is what? Na3Al(F6). Okay, fluorspar. Sorry, fluorapatite. Fluorapatite. Okay, calcium phosphate, Ca3PO4 taken twice along with calcium fluoride. Along with water, calcium fluoride. So it means that these are exist in the combined state because they are very reactive. Even they are present in soil. Even they are present in soil. They are present in bones, teeth, etc. Teeth, etc. Whereas if you go for the combined state of chloride, like what are different salts are there? Other than that, one of the important ore as one of the important mineral of this one chloride as kernelite. What is kernelite? Kernelite, potassium chloride, magnesium chloride with 6H2. It is what, children? It is the composition of the kernelite is potassium chloride, magnesium chloride along with water. Along with water. So other than that, we can say that what are the trends are possible? What are the trends are possible for group 17? All these are for general introduction. Where they are present. Okay, seaweeds contain, even the seaweeds contain halite high concentration. So other than this, we can say that many of the salt, like the sodium chloride, or we can take the example like magnesium chloride. Even the seawater contain, seawater it is a brine solution. It is a composition of water. Potassium chloride will be there, sodium chloride along with magnesium chloride and calcium chloride. Many this one sources are there from where the halide can be extracted. Halide can be extracted. Let us move to general trends of group 17 elements. General trends. Like electronic configuration, atomic size or ionic size, ionization enthalpy, electronegativity, and electron gain enthalpy. These are the familiar. Even in the first class itself, as I said, children, whatever the point we are going to discuss in group 15, same are going to continue in group 16, group 17 and group 18. Okay, like this we can discuss one by one. Let us write what the electronic configuration, general trends. General trends of group 17 elements. General trends of group 17 elements. Like the first one, electronic configuration. Electronic configuration. Electronic configuration is NS2NP5. It is a need of one electron to complete their octet. By accepting one electron, it can become noble gas. It can become what? Noble gas. Whenever we are going to say with respect to electronegativity, that time you will see that these are the most electronegative element. Most electronegative element. Like the atomic number of fluorine is 9, chlorine is 17, bromine is 35, and iodine is how much? 53. We are not worrying about this one. Astatine is 85. We don't want that. We write electronic configuration for fluorine as helium. Helium 1s2. Okay, 2s2, 2p5. Same way with respect to what, children? Chlorine 17. Neon. Okay, 2p. Sorry, 3s2. 3s2, 3p5. Always remember that whenever we are going to move down, the principal quantum number is going to be increases. Like bromine, shall I write here? Is it visible to you? Bromine, we can write it as 35, helium, neon, argon. Argon, okay, 3p, 3d10, 4s2, 4p5. 4p5, okay, 4s2, 4p5. Down the group, we are going to increase one by one. principal quantum number. Okay, same way. Iodine, helium, neon, argon, krypton. Okay, 4d10, 5s2, 5p5. In all the cases, we can observe that they are having what the p5. They are having what, children? ns2 np5 electronic configuration. ns2 np5 electronic configuration. So we can say that ionization enthalpy will be high. In the next class, we'll see how the ionization enthalpy, electronegativity, and electron gain enthalpy are going to vary in case of group 17. Okay, today I have given only one question that you need to answer, children. Okay, next class we will continue. Tomorrow, this one, group 17, will try to complete, or else by day after tomorrow we can complete 17 and 18 also. 18 is very small. They have given in the updated portion. Okay, thank you, one and all.